Good morning, students. Today I am going to explain theorem 10.5. Theorem 10.5. The theme of the theorem is there is one and only one circle passing through three non-collinear points. Before proving this theorem, I am just going to clear non-collinear points and collinear points. Look at here, students. Collinear points and non-collinear points. Three or more points are said to be collinear points if they all lie in a same straight line. Again, here consider 3 points A, B and C. These points are said to be collinear points because the 3 points A, B, C lie on the same straight line. So we conclude that three or more points are said to be collinear points if they all lie in a same line, means same straight line. Non-collinear points here are PQR are known as non-collinear points as they do not lie in a same straight line. Always 2 points lie on a straight line. Okay, while 3 points here not lie in a straight line. If we join these three, a triangle is formed, a polygon of 3 sides is formed. Okay, so what we prove in this theorem? We are going to prove that there is one and only one circle passing through three non-collinear points. Right, students? So given, what is given condition here? Three non-collinear points are given condition here. So three non-collinear points. Just take three non-collinear points A, B and C here. Right? And what is figure? Here figure is, just I am drawing we already know that there is one and only one circle possible through three non-collinear points. So here are the 3 points. Here are the 3 points. Point A, here is B, another is a C point. Okay, so what we prove here? We prove that to prove there is one and only one circle passing through A, B and C, three non-collinear points. Here construction is required. Given condition is not sufficient to prove this theorem. So we construct that join AB and BC. So AB and BC को हम join करते हैं. Join just AB and BC. Right? Draw perpendicular sectors PQ and RS of AB and BC. Right? So perpendicular bisectors PQ and what? This is PQ and this is RS, R and S. Right? So they intersect at a point named as O. Okay, so join AB and BC join AB and BC. Two chords are formed. Draw perpendicular bisectors of AB and BC. The perpendicular bisector of AB is PQ, while the perpendicular bisector of BC is RS. They intersect at O. Right? Clear? As what you conclude here? As A, B, C are not collinear, non-collinear points. So what you conclude? So that implies the perpendicular bisectors of AB and BC what are not parallel. They are not collinear points. A, B, C are not collinear points. So positively the perpendicular bisector of AB and BC are not what? Parallel. So that implies let PKO and RS intersect at a point O, right? So this is the point of intersection between these two perpendicular bisectors of AB and BC respectively. So join OA, OB and OC, right? So what you write here? Join OA, OB and OC. Clear? Now prove that. This is construction. Now prove that. Proof. Okay. So students, again I am going to draw the figure. This is A, B, C. Join BC, AB and BC. This is PQ and this is PQ and RS. They are intersect at a point O. Then join OA, OB and OC. Let us prove now. Since O lies on the perpendicular bisector of AB. O lies on the perpendicular bisector of what? AB. PQ is the perpendicular bisector of AB and O lies on it. So what you conclude? So positively OA is equal to OB. Okay, if we take these two triangles, then we and congruent them, then what you conclude? These two triangles are congruent by side angle side congruence rule. So that implies OA is equal to OB. Okay, so OA is equal to OB. Again I am repeating the same things. As the point O lies on the perpendicular bisector of AB, so clearly OA is equal to OB. Why OA is equal to OB? We just compare these two triangles. OA, suppose this is T. Suppose this is, I am taking T. So OAT triangle and with OBT triangle, AT is equal to BT, as PQ is the perpendicular bisector of AB. OT is the common side for the both the triangles, and okay, and this is 90 degree. OTA angle equal to OTB angle. These are the perpendiculars. So AT is equal to BT, OTA angle is equal to angle OTB, and OT is common for both the triangles. So these two triangles are congruent by side angle side congruence rule. So that implies after congruence OA is equal to OB by CT. Okay. Similarly, O on the perpendicular bisector of BC. So that implies what you conclude here. OLA is perpendicular bisector of BC. Okay, RS is the perpendicular bisector of BC. OLA is on it. So positively, similarly in this process, just previous process, OB is equal to OC. So that implies OB is equal to OC. So what you conclude? Here we conclude OA is equal to OB. Here OB is equal to OC. So that implies OA equal to OB equal to OC. We say R say. So taking O as center, we draw a circle with radius R. Okay, and which will clearly passes through A, B and point C. Clear now? But what the question is asking? The theme of the theorem is there is one and only one circle passing through three non-collinear points. Again, there is something remains. Actually, the word only one is here. So again, there is something remains to prove this theorem clearly. Okay. So now we already proved that. I proved that through these non-collinear points ABC, a circle is drawn. Now we prove that there will be only circle be constructed through these three non-collinear points. So what you write now? Let us assume that O dash will lie on the perpendicular bisector of PQ of AB and RS of BC. Right? Students, suppose let us consider that suppose already we constructed and clear that O is the center of this given circle that can be drawn through these three non-collinear points. But let us assume that this is not sufficient condition. So let us assume that there is a point O dash which is lie the perpendicular bisector of PQ and RS. Right? So what you conclude here? Since two lines cannot intersect at more than one point. So that implies O dash must what? Coincide with O. What you assume just previous? Let us assume that O dash will lie on the perpendicular bisector of AB and BC. Right? But we know that two lines are intersect. If two lines are intersect, there will be one common point between these two lines. Here PQ and RS are the perpendicular bisectors. Okay, they are the two lines. So they intersect only one point. So that implies what you conclude? O dash and O are unique point, not two different points. Because if two lines are intersect with each other, there will be one point in common between these two. So positively O dash and O are unique points. Clear now? So what you conclude here? So that implies OA equal to R. Okay. OA is equal to R, and suppose O dash A is equal to S, and O and O dash and O coincide. Coincide means unique point, only one point, not R 2 points. So positively R is equal to S. What you conclude here? Two lines, if two lines are intersect with each other, then there will be one point in common. Means one point is the point of intersection, right? So that implies O dash and O are not two different points, they are the unique points. So in the previous we conclude that OA equal to OB is equal to C is equal to R. If suppose O dash A is equal to S, O dash A is equal to S, O is equal to R, but O and O dash are unique, coincide here. So that implies R is equal to S, right? They have the same radius. Clear? So that implies COR. That means center O and radius R is positively congruent to center O dash and radius S. So what you conclude here? Hence, there is one and only one circle passing through the three non-collinear points A, B and C. Hence proved. Okay, students. So what you conclude at last? There is one and only one circle possible, three non-collinear points. Thank you, students. I think you all understood me. Thank you.